During the design process of a corridor, one of the things that you have to do is to work on the roadways, the shoulders, curbs, sidewalks, etc. And then you'll have to work on your end conditions tying to ground. One way to expedite the processing speed of the corridor is to not have your existing ground surface active until you're actually going to be working on the end conditions. Because a lot of the processing requirements for the program are done within the end conditions. And so if I select my active surface and I clear the activation of the terrain model so I don't have an active surface, then as I reprocess my corridor, I'm going to take out the processing times required for the end conditions, and it's going to process quite a bit faster. And then once I start working on my slopes, then I can reactivate my active surface. Looking at our existing ground terrain, and especially the width of the terrain that we have to consider the fact that the program actually goes all the way to the edge of the existing terrain boundary when it processes, even if we tie down much sooner than the edge of our data. And so one of the things that we can do to optimize processing is to minimize how far out of our design area we maintain an existing ground surface. So in this simple example, I drew a rectangle inside of my typical existing ground terrain model, and I'm going to show you how to build a clipped terrain that we could use for our actual design process. And so in our task, we'll come over to our terrain modeling and we'll select to create a clipped terrain model. And you'll see I have the clipping method set to external. I have a feature definition set, and I've given the terrain model that I'm going to create a name. And so I'm just going to follow the prompts here to locate the existing terrain model, locate the clipping element, reset because I don't have any other clipping areas. Horizontal offset and vertical offset would be 0, and I'm going to clip everything external to my shape. And now you can see that I have a new terrain model that I can use that is smaller and will process faster. In this next situation, we want to take a look at how we can control points vertically. In this particular scenario, I have a widening project where I want to match my existing cross slope, and I want to take a sample of the existing ground at 4 feet right and at 8 feet right, and I want to begin my widening at 11 feet right, and whatever the slope is at 4 and 8, I want to continue that slope from 11 until the edge of my proposed widening. So there's a couple of ways that we can do this, one more efficient than the other. In this first example, I'm actually setting point controls on these two lines, and so I have an alignment called EX1 and I have an alignment called EX2. On each of these alignments, I have assigned the existing ground as the profile to dictate that vertical information, and so you'll see these gray lines here that represents the 4 and the 8 foot where the profile is set by the ground. And then if I take a look at my template, what I've done is I have a 4 foot point and an 8 foot point. Each of these are constrained horizontally and vertically, you can see to CL, and this one is constrained also to the CL point 8 feet out, vertically at 0 because our profile will override the vertical. And then this point is then going to be a vector offset between 1 and 2, and this point will be a vector offset again between 1 and 2. There's absolutely nothing wrong with this approach. It will work, it will give you correct results, but the issue really is in this topic is processing speeds. So let's take a look how we can set this up differently. So I'm going to switch templates to one that looks exactly the same. I called it project to surface. But if I go now and I look at this point EX1, instead of a vertical from CL, I'm setting it to project to surface, and the value is the active surface, and I do the same thing then on EX2, project to surface, any direction, active surface. And everything else remains the same. So just two simple point constraint changes. And so what I did on my project then is I simply changed to that particular template where I'm using the project to surface template, and I deleted my point controls, and you're going to see that my matching existing is going to exactly be following, if you can imagine, a point here at 4 feet and another one at 8 feet. It'll be projected through that plane, and then match the existing based on those parameters. And so I really don't even need those point controls now because I'm parallel to my baseline. If I weren't parallel to my baseline, perhaps you might need to use one of those point controls and alignment for simply a horizontal control and not a vertical control. The key here is to not use the vertical profile of the existing ground if you don't have to. Sometimes our users are getting confused when they're prompted for a desired template drop interval when building a corridor. And so just to show real quick that particular prompt, when we create a corridor and we give it a name here, it's going to ask us to select our template and our range. And this is the prompt that I'm referring to. The best way to explain this prompt is think of this as what is my maximum spacing on a tangent portion of my alignment when there is nothing changing horizontally or vertically or with superelevation. In other words, a straight line, normal crown situation with a flat profile. That is what it's asking for. And getting feedback from contractors and machine guidance, they suggest this value could be as high as 25 feet. We're recommending 10 feet as a good compromise. Anything less than 10 feet is so much data that by the time the contractor gets it, they really have to thin it down a lot. And so the suggestions, it seems to be pretty unanimous that every 10 feet is a good compromise in terms of accuracy versus speed of processing. Now that we understand the concepts of a template drop interval, the next thing I want to talk about is the template drop multiplier. In the last video we showed we had a template drop interval of 10, but yet if we look at the spacing between two drops in our model, it's actually 100 feet or 100 master units in our example. And that's because in the corridor design stage we had chosen was zero-functional, had a template drop interval multiplier here of 10. So it takes our number 10 we keyed in times the multiplier set to the design stage, which is 10, and therefore shows a section every 100 feet or a drop in our model every 100 feet. Why do we do this? Why do we use these design stages? These design stages allow us to still work on our corridor but take out some of those drops to make it process much faster. And so as we go, from example, from a functional design stage to a preliminary design stage, notice now our template drop interval multiplier is only 5, and so we should see cross sections now every 50 feet. And so if I go to my corridor and I go to my quick properties and I change this then to my preliminary design stage, I'm going to get twice as many cross sections on my corridor. So I'm going to make it more accurate. If I as I'm starting to work on that final design, then I can switch to perhaps a design stage, etc. And so based on what design stage you have, it's going to directly affect how fast your corridor will process. Now that we understand design stages directly affect our corridor, you can see some different examples here that the state of Utah is using, and we've made some changes that I think are good from the examples workspace. For example, we made a copy of the number 2 design and we give it a name, design with external controls on. But I just want to go down here and look at some of these differences. The functional from the examples workspace and this new example is the same. But on preliminary, we've turned off external control points and densification of horizontal curves. On design, we did turn on horizontal curves, densification, and left off external control points. And then on this other design one, we do turn on the external control points. And then on final, everything is on the include of critical sections, but we are not turning on, for example, the meshes. And then the 4, 5, and 6, typically those are just for visualization, looking at your model. It's not necessarily something that you need to do for terrains or for machine guidance. There's other ways, better ways to create terrain models by using graphical filter definitions. Then the last one here is the final with linear features. This one sometimes is used to generate or to take a look at all your break lines, and then final components turns off your break lines, and again is more either for quantity calculations or visualization. But the focus here really is basically 0 through 3 here. I want to really talk about what we're doing with these settings. It's important that you understand what horizontal vertical cardinal points are, external control points, as well as densifications. Horizontal control points will essentially add an additional template drop anywhere there's a change in horizontal geometry. For example, the PC or the PT of a curve would be a good place or a good way to understand that you will get additional template drops set if that is set to true. The same thing with vertical cardinal points. If you have a vertical VPC, a VPT, a low point or a high point of a vertical curve, a change in tangency, whatever, you're going to see those additional template drops added to your model. External control points, the best way to explain this, say for example you're targeting a alignment that represents a wall, and you would, if you turn on your external control points, you're going to get at minimum a template drop at the beginning of that alignment and at the end of that alignment. You're also going to get template drops anywhere there is a bearing change or a PI within that alignment. And so your external control points evaluates those point control alignments you're using and adds additional sections. The densification of horizontal and vertical curves, this by far are two of the most important settings in terms of the accuracy of your model. What this does is it reads a configuration variable shown here, one for the profile and one for the horizontal curve. One of the changes that we're recommending is to change this to 0.1 and 0.1 instead of the default of 0.5 that is delivered with the examples workspace. This feedback came directly from couple of major contractors here in the U.S. saying that 0.05 is just too tight, and they end up having to do a lot of data thinning to get the data into their machine guidance. They will even take these numbers as high as 0.2 and still have very accurate results out in construction. And so those are two changes that we are recommending for you to consider. And then on the design stages, just to kind of help with speed a little bit more, on the preliminary we're turning off control points, and we're also turning off the horizontal. And then on this second, these two parts of this design phase, one is going to be without the external control points turned on, and one is going to be with the external control points turned on. And then of course final we're going to leave as is in the examples workspace. And so I'm going to deliver this updated DGN lib and the updated configuration file on this wiki that has these design stage changes in there, and you'll just copy those over to your examples workspace, and that will go ahead and update them. Now, should you already have a project started and you want to take on the changes, you'll see here in the civil standards under project settings in my file itself, you simply right click on the header of corridor design stages and just select update from library, and then it will adopt the changes that were made in the DGN library itself. I think that you're going to see with the changes that we made to the configuration variables, also with the changes made to the corridor design stages, and tweaking these settings on the critical sections a little bit, you're going to see much faster speeds on the processing of your corridors. In this example, I want to show you how you can take advantage of increasing template drop intervals on areas that you're not working on. Here's a real job, and every template drop interval here is set to 10. But let's just say that I'm working from station 300 to station 323. What I can do here is I can come to the rest of these in Project Explorer, the civil model. Under my corridor, I can select these template drops using my shift and my mouse key, and I can just change 10, for example, to 1,000. And what that's going to do is going to drastically cut out how many templates I'm processing along my corridor and allow me just to focus on the tighter interval in the area that I'm working on. And then I can come back and change these later, and it's going to really expedite how quickly things process. One question we get a lot is about actually creating a top and bottom mesh, thinking that that's what we need to do to get a proposed terrain model. And I'm going to suggest that we don't use the option here in the output settings of our design stages to create a top or a bottom mesh. It does take quite a bit of resources to be able to maintain those, especially on large projects. And we do have a better way of actually creating graphical terrain filters and then to terrain models. There's a video out there on our wiki that directly addresses that situation. And so we suggest in terms of preparing for machine control, doing your design, there's just it's not necessary to set these, and it's definitely going to make processing faster to leave those set to false. Another question we get a lot is how accurate do we need to be and when do we need that accuracy? We have in here a core design stage called 3-final, and what that does is it makes all of our settings such that it's going to give us the most accurate possible terrain model. And so typically I instruct the users to stay within at the most 2- design or 2- design with external control points on before you go to finalize your design. And when you're ready to build that iModel or send it out to construction, switch to your design stage before you do that, and also reactivate your existing surface. And so you'll see here in that final design stage, your template drop interval multiplier is 1. All of your critical sections are processing now, and you are still are not producing meshes. You don't need that for accuracy, but this is going to by far give you your most accurate results in terms of preparation for the iModel and for construction. But I would only use the final design stage when you're at that phase, because essentially when you look at the differences between design and final, even if you're using design with external control point set to true, you're still only taking away the densification of vertical curves, which is going to be hardly noticeable when you're actually doing your design work. And it does also use a multiplier of 2, so it essentially processes twice as fast as the final design stage. And so I typically reserve the final design stage to only be used as I'm preparing for the iModel. Another important aspect to reducing the time of processing when you're doing work within corridor designing is to take advantage of corridor activation of the rules. So if I select a corridor here, for example, you see this padlock, I can select that it's locked right now, but I can select it to deactivate it or let it think that it's not a corridor. I can get to that same tool over in my corridor objects dialog. You will see the padlock here at the top of the screen as well, where I can deactivate the corridor rule. And the other place that I can get to it is in Project Explorer within the civil model. I can right click on the corridors, and it doesn't matter how many corridors are in my file. If I deactivate, it'll deactivate the rule for all corridors in my file. Now, why would I want to do that? Well, let me give you an example. Let's say that I needed to add several key stations to my design. I can select on my corridor and I can deactivate its rule so that it won't automatically process. Now I can go in and add point controls. I can add, key stations, whatever I want to do. Let's say that I want to, just as an example here, add some key stations. So I'll put one here, and then I'll go ahead and put one up here. Maybe I'll put one up there. And notice that I'm not doing any processing while I'm adding those key stations. Then once that I have completed my task, I simply go back to that corridor and turn on the rule. And notice that it doesn't process. It won't pick up those changes until I either manually select to process the corridor or I go add another command that forces it to reprocess. Then it'll process that next command plus the 3 that I just did. And so taking advantage of activating that rule or deactivating that rule allows you to make many changes without having to wait for reprocessing. In our examples workspace, if you take a look, for example, at the 2-lane urban curb and gutter with sidewalk template, I can test this point control by right-clicking and test horizontally. And notice once I move past the center line, everything to the edge of the pavement turns off. Why is this significant? Well, one of the ways that we can save time in processing is when we have, for example, a side road coming into a main line, we need to clip that area out. One of the things that I've done in that template, and there is another video out there that is dedicated to this topic that walks you through how to set all this up, but essentially there is a display rule on that curb and gutter, and we take a look real quickly at that. It just compares the distance between that seek point and the baseline point. And so if we look at what that point is actually seeking, it's seeking a feature definition horizontally, and you'll see that here. Call it feature definition called match line within 100 feet to the right, and then the left side is seeking one 100 feet to the left. And so if we draw that match line in our model, what that's going to allow us to do is to not have to issue a clipping reference. And so if I just go place a match line out here in the general area, notice it doesn't do anything, so I have to go to my corridor and I have to add that as a reference to my corridor. And so you're in your corridor, add reference, and we'll select that, reset, and then that'll go ahead and have everything stop drawing at the edge of pavement. So then I can place my civil cell and not have to add that civil cell as a clipping reference to the corridor. You want to try to avoid adding clipping references to your corridor as much as possible. This is by far the one thing that takes the most hardware intense resources, and so I typically tell people if you cannot do clipping references right now until we get into the 64-bit platform and optimize that better, I would suggest that you take this approach and you can go in and place as many of these lines as you want, add those all to a reference to the corridor at the same time. And there are other videos out there that shows how to place a civil cell and how to add the key stations at the end of the fill, etc. The point of this video is to show you that there are better ways to have that not draw beyond the edge of the pavement by using this approach of using component display rules with parent-child relationships on your templates seeking match line. Another tip is to take advantage of using parametric constraints over point controls. We take a look here, our corridor is already drawing our edge of pavement for us. It's essentially a child of the corridor because on the linear feature we turned on the property to automatically create that template geometry in our 2D plan. So I could go out here, for example, and draw a lane line that tapers from 12 feet to 24 feet, or I can just use a parametric constraint instead of targeting point controls. And so if I go out to my parametric constraints, and let's say, for example, I start at 7 plus 50, and I'm going to end at the end up here, which is going to be 9 plus 98. We'll accept that, and then we'll go ahead and tell it what constraint we want to modify, and that's just going to be our right pavement width parametric constraint. And we're going to start at a value of 12, and we're going to end at a value of 24, and we instantly have our line taper and our edge of pavement drawn now in the proper location. Using the parametric constraints is a much more efficient way to manipulate our corridor versus targeting plan graphics and alignments. There's not anything wrong with point controls, it's just in terms of speed and efficiency, parametric constraints are faster when they process. Regarding corridor references, for example, if I wanted to perhaps target this line right here sometime in my design process to have a template point follow it, I can go in and I can select my corridor and I can go to add corridor references and I can add that particular line as a reference to my corridor, and it'll be able to then be used as a target when I'm actually working on point controls in my templates. But what we've seen a lot of problems with our users is they will go in and actually go ahead and add everything as a reference to the corridor thinking that they might need it. And what happens is it actually has to process all of these lines as that corridor is developing. And so the recommendation is to only add a reference to the corridor when you absolutely need it. Using the dynamic cross-section view is a very common thing to do when we're detailing our design, looking at different ditch flow lines, that type of thing, and making sure everything looks right. And we'll actually go in, we'll open up our dynamic cross-section view from our corridor, we'll resize it, and then we go up here, we do a file, save settings, and then we close out for the day, we come back in the next day, and we realize that we have to wait for everything to reprocess. And what happens is when that dynamic cross-section view first opens, it has to process your entire design. And so one of the things that we recommend is, if you're going to close out and come back in later, just go ahead and close that dynamic section view, save your settings again, and then only open it when you need it and close it when you're done, because that dynamic section view does require a lot of additional processing as things are done, and so we'd recommend closing it except when you need it. Another obvious but sometimes forgotten technique to really long projects, for example, this project is almost 14 miles long, It went from station 300 plus 00 all the way up to around 490 plus 00. Don't be afraid to take your initial design and do a save as. And for example, I saved this as corridor 1 of 3, and I deleted everything beyond this particular template drop. And then you go back to the original, save off as 2 of 3 and 3 of 3. Then you can make a blank container file just called all my corridors, reference in the 3 corridors together to have a completed model and referenced in as one file. But what this is going to allow you to do is going to process things very quickly. You take a look at this corridor now. When I go to process, let's say that I change to a design stage here. It's just processing here in a matter of seconds and I'm done, versus waiting, a couple minutes before. You can see that I'm already done processing that entire corridor. And so don't be afraid on really long jobs to break it up a little bit and then reference them all together into one file to see your entire projects from beginning to end. This particular tip involves superelevation, and in particular the superelevation lane objects and the colorization or the fill. One of the things that we suggest on larger projects is to go to your workspace preferences, your view options, civil, to your superelevation settings. Change this from color shaded fill to boundaries only and say OK to that. And then when you select your superelevation object, you can still go in here and graphically change things. But the rendering of those lane objects does take quite a bit of horsepower. So on large jobs with superelevation, it's better to not have that fill on, and you will see increases in your processing speeds. This last tip is going to deal with nesting depths when we attach references. Let's say, for example, we want to cut proposed cross sections. Well, to do that, we're going to need obviously our existing ground file, and so by referencing my terrain, notice that we have in the examples workspace a default here of 1. I'm going to change that to 0 because all we need in that file is that terrain itself. And so if we do a fit view and we set that to active as our terrain model, it should be ready to go. And then the next thing that we need to do is we need to attach our design file. Now, some people tend to think that, well, if we're attaching our design file, it has a 2D model and it has a 3D model. So let me show that to you. You can see, do I need to attach the 3D or the 2D? All you need to do is attach the 2D and set the nesting depth to 0, not 1. It will automatically bring in the 3D model. It knows that it needs it. And so I will select default model, the 2D default model, and a nesting depth of 0 to bring in my design. And now I can go in and cut my proposed cross sections. Now, some people have reported that they don't get to see their 3D model, and so I'm going to come in and open up that 3D model here for you real quickly. But we have our 3D model. You can see that it's all there. And so now if I proceed to cut my cross sections, I can just pick an alignment and go. But the point of the matter is, or what I'm trying to demonstrate here, is these nesting depths they seem to be causing people trouble sometimes. You can see where it created the model, it used the default that we had coming out of the configuration variable, and I'm going to talk about that next. But you see on the ones that we referenced in design and terrain, those are both set to 0 as we would want. And so to get everything to stay at 0 and only use it when we need it, in the examples workspace in your project configuration file, there's a line here where this default is set. It's called the MSRef default settings. And so again, I'm going to give you this new configuration file that'll have that change in there, and you can just simply replace that in your workspace. But we want to try to avoid using nesting unless we know we absolutely need it to bring it in, just to try to limit what we're requiring of our resources.